For what value of b is the line y equals 10x tangent to the curve y is equal to e to the bx at some point in the xy plane? And we have a bunch of values of b given here. Okay, this should not be terribly difficult. So if we're tangent, let me write down the equation of the two functions we have here. So if these two curves are tangent to each other, then this happens at a value of x when 10x is equal to e to the bx. But we also need the derivatives to be equal. So we need 10 to be equal to b e to the bx. So this gives two equations and two unknowns. I have to solve for x, and I also have to solve for b. Although really, I don't need to solve for x. It's only asking for the value of b, but it might just be easier to solve for both of them here. First thing I notice is that if I divide the first equation by the second equation, then I'll get rid of those exponentials. So if I do that, I have 10x divided by 10 is equal to e to the bx over b e to the bx. So there's a bunch of cancellations there, and I have x is equal to 1 over b. So this is the value, this is the relationship I need between x and b for this to hold. I'm now going to substitute x is equal to 1 over b in the first equation. So I have 10 over b is equal to e, and I have b times x, which is 1. So I'll just write it like this. So this says that b is equal to e over 10. And I hope that's one of the multiple choice answers that's given. It's not. Oh, because of course I did this incorrectly. It should be 10 over e. Yeah. If you rearrange the equation above, 10 over e. And that is option A. So pretty straightforward. I guess the key piece of information here is if you have two curves that are tangent to each other at some point, it means not only do they intersect there, that gives us the first equation, but their derivatives must be equal there, and that gives us the second equation. And then it's just a question of realizing what algebraic steps you can take easily to solve for one or the other, or in this case, found a relation between the two of them. So yeah, I don't have much more to say about this one. Thanks for watching.